Right, so we're back. We are now continuing with this unit. So we talked about exponential growth and decay last time. It had this formula, and we also mentioned our compound interest formula. So we're going to keep building on that. Now let's say you deposit $100 into an account, and the bank generously gives you 100% interest rate for the year. So that's going to look like 1 plus, we know 100%, move it back twice, it's just 1. And after 1 year, this will just be 100 times 2, you'll have $200. So your money doubled. But when we talk about compound interest, let's say they give you this 100% interest twice a year. So every 6 months. That means you'll get the 100 first, and then you'll get another 100%, but you get it twice. So if you get it twice, you'll end up with $225. So that's more because it compounded twice, whereas here it only did it once. So the more times your interest is compounded, the more money you should get. So let's say they want to do it monthly. Well, how many months are there in a year? We still have this interest rate, 1 from the 100%, and we're doing it 12 times. So if you do this 12 times, you'll get $261. Okay, but let's say it's compounded daily. 365 days in a year. So when we do this, we get 271, approximately. The dollar sign should be in front, by the way. So that brings us to our point of continuous. 365 is daily. If we are compounding something continuously, we are going to use this irrational number, e. So just like pi equals 3.1415, blah, 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 e is some number just like that. So if we do 100 times e, we get 271.83. And that is what we're going to talk about today. But I want to explain more about how E is found. However, it's a lot of calculus that I don't think is prudent for this lesson. Alright, so on this page are just our two formulas that we're going to work with today. Compound, which is the formula I gave last time, and then continuous is our new formula. So I would pause the video and make sure you write these things down in your notebook, and we're going to do some example problems. So the first example, and I'm going to read all the problems just because I don't know, the video, when it uploads, it gets very sketchy. So this problem says an initial amount of $3,500 is invested in an account at an interest rate of 9% per year, compounded continuously. So whenever you see that word, we know we're using this formula. So I'm going to stop everything I'm doing, write down the formula. Assuming that no withdrawals are made, find the amount in the account after 2 years. Do not round any intermediate computations and round your answer to the nearest cent. So we're not rounding anything until we get to our answer. So this is our formula. We have these values here. 3,500, 9%. And because we're investing, we know it's increase. So we have A equals 3,500. E, our rate is 9%, so 0.09. And then we want to know how much is in this account after 2 years. So we're multiplying. So if we put this in the calculator, we get $4,190.26. And that's our answer. So again, once you see this word continuous, write down our formula. Then we're just plugging in values, putting it in the calculator. And the way you should put this in, 3,500, then you press second, and then ln. Something will come up like this, in the parentheses, 0.09 times 2. So the way you put things in the calculator could get you the wrong answer. Alright, the next problem, Rita borrowed $8,000 at a rate of 12% compounded monthly. Assuming she makes no payments, how much will she owe after 6 years? Do not round any intermediate computations and round your answer to the nearest cent. So again, we don't see the word continuous, but we do see this word compounded. So if you don't see the word continuous, then we know we're using either compound interest formula or growth and decay, which kind of the same thing. So this is our formula. 1 plus or minus r over n raised to the n times t. We just have to fill in every value that we know. So she borrowed $8,000. The rate, 12%. Then it says 6 years. So if you're borrowing money and there's an interest rate on the amount you have to pay back, that money is going to increase. If there's an interest rate, it wouldn't decrease. So we have A, we trying to figure that out. P is 8,000, because that's what we started with. 1 plus, because it's interest goes up. Our rate is 12%, which 0.12 divided by n, which is, well, no, it says compounded monthly. So this is, n is the number of times it's compounded in a year. So there are 12 months in a year, so n is 12. And t is 6. So now we want to put this in the calculator. You could simplify this more if you want to, but again, it says don't do any intermediate rounding. So I would just put this in the calculator exactly how you see it here, and I'll write that out later. So when we put this in the calculator, we get approximately $16,376.79, which is double. So you borrow $8,000 and you got to pay back $16,000. Got to watch these interest rates when you start taking out loans in real life. So the way you should have put this in the calculator, because that will mess you, but if your answer comes out and it doesn't make sense, you know you did something wrong. So we have 8,000 parentheses 1 plus another parentheses 0.12 divided by 12. Make sure you have this double parentheses here. Then you do the caret raised to 12 times 6. That's how it should be entered in the calculator. Alright, and our last problem is we're just writing our function. We're writing a model to represent the situation. Right, at the beginning of a population study, a city had 270,000 people. Each year since, the population has grown by 7.2%. Let T be the number of years since the start of the study. Let Y be the city's population. Write an exponential function showing the relationship between y and t. So y is the city's population. That's our output. And our initial amount, what we started with, was 270,000. You know this one is going to be here because that's 100% already. And it grows by 7.2%, which is 0.072. And t is the number of years. So that's about it. This is our function. Y being a function of t. So you can have y of t here. It just depends what they ask you. Either way is fine. But this shows the relationship between y and t. As t gets larger, y will get larger as well. Alright, so you should have everything that you need to do, or at least, mostly everything. You might have to apply some thinking at some point, hopefully. But just to recap, we have 3 formulas. This is exponential growth and decay, plus or minus. And we have compound interest. And compound interest is almost always plus, but just in case. And we have continuous. So continuous, compound, growth and decay. So what I would suggest, look for these words. If you don't see continuous, we're not using this formula. Then you look for the word compound. If you see that word, we're using this one. If not, then we're using growth. If you have any questions, feel free to email me or text me if you have my number. And good luck on these assignments.